Think about all the devices that you use at home on a regular basis, such as your lamp, television, computer, or stove. What do these appliances all have in common?
They are powered by electric current?
Okay, but more specifically,
They're powered by AC current?
that's right.
But what exactly is AC current?
So there are two types of current, AC and DC.
Isn't direct current the flow of electric charge in only one direction?
Yeah, an AC current is the flow of electric charge that changes direction at regular intervals.
Because the voltage and current remain constant in DC current, its graph of voltage as a function of time will not be sinusoidal. It's a linear function.
For example, this graph shows a voltage of 6 volts DC current and can be represented by the equation V equals 6V.
On the other hand, the voltage and current are constantly changing in AC current.
At its rest position, the voltage starts at 0 volts, increases to a positive maximum, falls to its negative minimum, returns to 0 before repeating this cycle in a wave-like pattern.
This graph shows voltage as a function of time in an AC circuit. As you can see, it is sinusoidal.
Wait a minute. How would someone create these graphs?
Good question. We can use an oscilloscope, a device that produces an electron beam used to create graphs.
To write an equation for the graph, we must determine the amplitude, period, phase shift, and the equation of the axis.
The maximum is 170 volts and the minimum is negative 170 volts. So the amplitude is 170 minus negative 170 divided by 2, which is 170 volts.
The axis can be determined by the equation V equals 170 plus minus 170 divided by 2, which is just V equals 0.
The period is 16.67 milliseconds as determined from the graph. This represents 0.01667 seconds. To determine the K value in the equation, we divide 360 degrees, which is the period of the parent cosine or sine function, by the period. So 360 degrees divided by 0.01667 equals 21,600. This graph starts at its axis, V equals 0, and then goes to its maximum, similarly to the parent sine graph. Therefore, it would be easier to create the equation of this function in terms of the sine function, because then we will not have to apply any phase shifts.
However, if we use a cosine graph, we must use a phase shift of 0.0041675 degrees to the right. The graph of cos theta starts at its maximum, so we must shift the graph to where its maximum is. We see that the maximum occurs at 1/4 of the period from the graph. So we divided 0.01667 by 4 to get 0.004165.
Created using Powtoon.